afternoon. My name is Charles Roberson. I'm going to be talking to you about something that's become near and dear to me. A project I've been working on for about 3 years. It's called the DFG 1901, the Directional Force Generator. The reason this is important to me for so many reasons. I see it as a device that's going to change a lot of the world and how things are done. It's a device that uses weights, masses, for the better term. Solid piece of metal, spun at a high rate to create a lot of force. What's important about this is that all you require is a methodology, first of all, and then a motor, electric motor. It doesn't require huge amounts of fuel. It's self-contained. Produces a lot of power and can be very small. The one I'm working on right now can be attached to this chair, say. Two of them, one on each side, and a stabilization system could be used to lift this chair and take me anywhere I want to go. What started me on this was a patent by Nikola Tesla, who passed away some 60 years ago, who was working on a device called the flying stove. He said his flying device would be no bigger than a stove and would be more stable than any aerodynamic flying device out there, like an airplane. I think he was right. Basically, what we're going to do with the DFG 1901 is we're going to take this weight, and we're going to spin it. We're going to spin this real fast. Anybody who's ever spun a belt above their head, chasing other kids around when they were younger, knows that when that belt slaps you in the head, that belt buckle weighs a lot more than it did just sitting still. That's called inertial force. Okay, inertia. Inertia is constant, whether it's at work, sitting still, or if it's in motion. A mass is. Okay. Centrifugal force, another part of this equation, is what causes the mass when it's released. Say you're swinging that belt over your head and you let it go. It's what lets the mass, or causes the mass, to fly away. And then there's centripetal force. And this is the force that's a little more argumentative. Centripetal force would be the belt. Then you have the belt buckle, which would be the mass. Well, centripetal force is what holds the mass to the center, which would be your hand. Or you could think of like the moon, stars, and sun. Sun would be the center. The centripetal force would be gravitational forces that hold the planets in their alignments, in their orbits. Okay. Well, what we want to do is we're going to take this weight. We're going to let it build up a force. We're going to let that force release itself in the same spot every time. And use that force to create a directional motion. It's called linear direction, linear force. So this linear force, what's it going to be used for? Well, anything. If it's done properly and it's repeated constantly, 27 pounds can become 300 pounds. It can become more than that. It's self-contained, uses no gases, no compressed fluids, gases, explosions, no fans, no, anything like that. It's completely self-contained. A device such as this could be used to lift this chair with me in it. Basically, the reason I'm after it is I want to see cars fly. I really do. I want to see cars fly one day. I hope I live long enough for it. It's so important to me because I see this as a next step to us doing so many things on this planet. So many things we can create. It's a very green way of propulsion, system of propulsion. All it requires is electricity. And even that's going through an evolution right now. So, let's get back onto this though. This device could be used anywhere. Cranes, planes, trains, automobiles, blimps or dirigibles. Shipping. I mean, think about this. This device, when it produces its force, doesn't really care where you point the force. I point the force up, we go up. I point the force sideways, we go sideways. I point it that way, it comes straight at you. I point it this way, it goes that way. I point it backwards, and we stop. So it can be used in all kinds of ways, as a stabilization, as a braking system. It can be used as all that at one time. One of my things I like to talk about is trains. Trains are not my first concern, but I like to talk about trains because it illustrates the functionality of it. A train travels on a track. The reason we don't have super trains that go real fast is one, the size of the United States, and the topography is the other. The topography, having to go around mountains, having to go around cities, having to veer around just obstacles in general, requires that the trains not go so fast. They can't go so fast. And if they were having to make these curves all the time, they'd have to slow down. So they can't maintain speed. Reason being, centrifugal force would carry the trains off the tracks. They're going around the curve, they go off the track. We don't want that. This device here could be implanted in the floor, a larger one, in every other car. Not only could it be used to motivate the train to give it speed, to move it, but say we go into the curves, and as it goes in the curves, we point the device opposite the curves, and it actually puts an opposing force against the centrifugal force carrying it over. Therefore, the train stays on the track. Now think about this also. These super large trains, these ones that are a mile long. A 1 mile long train doing 30 miles an hour takes a mile to stop. That's a long time. It's a long distance to stop. With something like this, a few hundred feet, a quarter of a mile, you can stop the train. Think about that. And we're not talking about stopping it from 30 miles an hour. We're talking about stopping it from 70 or 80 miles an hour. Even faster, maybe. Just think about that. So it could be used as a braking system again. Stabilization system. Offsetting the centrifugal forces. And its speed. What motivates it forward. There's so many uses for it. Let's consider shipping. A device like this, say 6 foot, several of them, laid down the center of a ship. Now what slows a ship down? Drag. How much water the ship is sitting in. How deep is she sitting? Some ships, say, sit upwards of 20 feet. Okay? That's a lot of drag. They have to defeat all that water. Okay? Use this device to lift the ship and then point the ship forward. No more would you actually have to have props in the water. Propellers in the water. No more of that. Propellers that kill sea life, that create such wakes and everything like that. There wouldn't be any more of those. That's an incredible thing. This could be used to lift a ship halfway up out of the water, creating less drag, meaning less fuel, which means more money in their pockets. Means me and you pay a lot less for things being shipped from overseas. Okay. And finally, my favorite thing, flying cars. And I do mean my favorite thing. I want to see them before I pass away. This could be attached anywhere. Using a gyroscopic control system, could balance it out really easily, and there you go. The cars wouldn't be cars anymore. It might just be the size of a large washing machine or stove. Just a squared object pretty much that you sit in with all your controls in it, and it floats and does its thing. So many things it could do. Outer space, this would be king. This would rule the universe as far as mankind is concerned for a while, until they discover something with magnetics or something. But this here, take this into space. You don't need to carry millions of gallons of fuel with you. There would be no more of that. Battery systems, rechargeable through your solar, solar means, solar regenerators and stuff like that. Take this in outer space, you can go forever. It requires not to push against anything. It simply takes the mass, lets it spin, and the force. Now if you notice something, I'll put this right here. When you spin this, or even just move it a little bit, it moved to the end. moves to the end. And we didn't even complete a full circle. And the faster you spin it, the faster it wants to eject out. Okay? Now it's that ejection that creates the force. That force is directed to the end. Okay? This becomes my centripetal force, which is directed back to the center, which was me holding it. And if you'll watch, my hand goes this way. It just draws it. The weight has a natural pull. Well, we're going to do that hundreds of times, thousands of times a minute. We're going to create this force. This force is a linear force, a directional force. Will go anywhere you point it. It goes up, sideways, forwards, backwards. It doesn't matter. Force doesn't care. It just goes. So what do you have? You have a self-enclosed device. It uses no gases, no fuels. Okay? It could be used on anything. Planes, trains, cranes, automobiles. You name it, blimps. So many options that you can have from this. It's very important to me. I really want to see something like this come to fruition. They've been searching for it for years. I've been working on this now for 3 years. I've looked at over 220 patents. And I am absolutely convinced, along with some others. I'm going to throw some names out there. Y'all can look these up yourself because they've got information that's out there that you can see. One name is Roy Thornton. Mr. Thornton has passed away somewhere back in the 90s. Late 90s, I think it was. His device, two offsetting masses that I don't know how to describe the rotation, but he was able to spin his devices in such a way that this 30-pound device of his, when laid into the bottom of a canoe, could move two men and the canoe through the water at around 5 miles an hour. Pretty fast. Another name. Oh, let me finish with Mr. Thornton. You can look it up. It's on YouTube. Roy Thorson. Okay. Inertial propulsion. You type those words in and you will find it. Number 2 is a Mr. Robert Cook, who has passed away himself, and his son has picked up the mantle. Rob and I are Facebook friends and have a little conversation here and there. Robert's, this is a pun, I didn't realize it, has cooked something up, and he's taken over where his dad left off, and he's developing his own, and I wish him the best luck. He's really got me enthused with it. But there's a couple examples right there of devices that do work, show promise. And what we're looking forward to is finding investors to help us develop this one idea, this methodology. I can't go into a lot here on the video because, well, I don't want to give mine away. If I can convince anybody to listen and want to talk, this will be on my Facebook page. You can always give me a friend request or just a message, and I'm willing to discuss it with anybody at any time. This is my passion right now. If I can get it worked out, it's going to make a lot of money for a lot of people, which I think I have. I've really got something here, and this is why I'm doing this. I've developed it, I've thought about it, and now I'm driving everybody crazy, and I'm asking for your help and your assistance. And if I can get that, I know I can get something done and accomplished. Either way, I'm going to keep working at it. And I thank you for watching this small video. Thank you.